Hello students, I'm back with the discussions. Okay, so yesterday in my previous video I discussed 5 questions which came in GATE 2014 paper of mechanical branch. So let's move forward and slowly we are going to discuss today also the next 5 questions which came in GATE 2014. So I discussed till the fifth question. So here is the sixth question. Let's proceed. A rotating wheel is supported at the ends. Okay, it is subjected to a point load at the center. The maximum bending stress developed is 100 megapascal. If the yield ultimate and the corrected endurance strength of the shaft material is 300 megapascal, 500 megapascal and 200 megapascal respectively, then the factor of safety for the shaft is. See students, since it is a rotating steel shaft, it is the case of fluctuating load first of all. Okay, so as we know, it is the case of reverse bending stress. Okay, so stress amplitude here will be zero. Why? Because sigma max and sigma mean both are equal and opposite in magnitude. So only stress will be sigma mean stress. Okay, so as we know, there are three equations: Soderberg, Goodman and Gerber. There are three lines. Okay, there is a graph between stress amplitude and mean stress. You must have studied in design for fluctuating load. If if you are having any confusion, just refer the chapter design for fluctuating load in VV Bhandare book. Okay, uh, so stress amplitude is zero here, and mean stress is 100 megapascal. You should be able to identify this by reading the question. So when stress amplitude is zero and mean stress is given, all the three equations will become identical. Okay, so sigma mean by SE is endurance strength of the shaft material, which is 200. Okay, is equals to 1 by factor of safety, or you can directly write this in this way: sigma is equals to S minimum of this by factor of safety. So SE is the minimum, so 200 by 100 is 2. Okay, so 2 is the answer. So the given range is 1.9 to 2.1 as per the answer key issued by gate committee. So the next question is: two circular cylinders, two solid circular shafts of radii R1 and R2 are subjected to the same torque. The maximum shear stress developed in the two shafts are tau 1 and tau 2. If R1 by R2 is equals to 2, then what is tau 2 by tau 1? It is a direct question. We know, everybody knows the formula for stress in a circular shaft. Okay, 16T by pi d cube, where T is the torque and D is the diameter of the shaft. So tau 2 by tau 1 means, here we can see that the torque, the stress, the torsional stress is inversely proportional to the cube of the diameter if we take every other parameters as constant. So tau 2 by tau 1 is equals to d1 by d2 whole cube, or we can directly write it as r1 by rq whole cube, or which is 2 cube, which is equals to 8. So 8 is the answer. Okay. Now let's see another question. Consider a single degree of freedom system with viscous damping excited by a harmonic force. By reading this line of the question, you should be able to click in your mind that it is the question of vibrations, forced vibrations with damping. So at resonance, the phase angle of the displacement with respect to the exciting force is. Okay, So at resonance, okay, at resonance it is asking the phase angle. Okay, so you must you must have remembered the graph between the phase angle and the frequency. If the frequency omega tends to omega n, which is the natural frequency, which is the case of resonance, so the phase angle goes to pi by 2. Okay, by remembering the graph you can easily tick the option. So the answer is option C. Okay, next question. This is the question from engineering mechanics. So let me read the question. A mass m1 of 100 kg traveling with a uniform velocity, be careful, uniform velocity of 5 meter per second along the line collides with the stationary mass m2 of 1000 kg. After the collision, both the masses travel together with the same velocity. Okay, so the coefficient of restitution, very simple. We know what is coefficient of restitution. It is the velocity of separation by velocity of approach. Okay, so the initial velocity of mass m1 was 5 meter per second, and after the collision both the mass travel together with the same velocity. It means again 5 meter per second. Okay, so here v minus v by 5 minus 0, this u stands for the initial velocity. So u1 basically is initial velocity of mass m1, u2 is initial velocity of mass m2, which is 0 as the mass is stationary mass m2. v2 and v1 both are same after the collision. So after substituting the formula you will easily get 0. It means no energy is lost because of collision between the 100 kg mass and the 1000 kg mass. It is actually not possible, but as per the question we are proceeding. So the last question for today is, which one of the following is correct? So option A, intermediate principal stress is ignored while applying the maximum principal stress theory. It's absolutely correct. Okay, how you can judge is, if you would have studied the maximum principal stress. So intermediate principal stress means at any plane in a particular body, at any plane, if a particular stress is maximum, that is called principal stress, but we have to take the maximum principal stress in case of maximum principal stress theory. So we are ignoring this intermediate principal stress, so it is absolutely correct. The second is, the maximum shear stress theory gives the most accurate results amongst all the failure theory. This is absolutely wrong. Why? Because it is the distortion energy theory which gives the most accurate results. The maximum shear stress theory gives the most safest result, actually, not most accurate. Okay, so as per the so option B is not correct. We got the answer, but I am explaining the rest of the two also. As per the maximum strain energy theory, the failure occurs when the strain energy per unit volume exceeds the critical value. Correct. This is the definition of the maximum strain energy theory. As per the maximum distortion energy, the failure occurs when the distortion energy per unit volume exceeds the critical value. This is also correct. It is the definition of the maximum distortion energy theory. So the answer is option B. Okay. Um, the rest of the questions will be discussed in further videos. Thank you, students, and all the best.